young kid, the word patience used to get on my nerves. For me, it was just an irritating word, and I had to wait even longer for something I could have straight away. But here is the true power of patience. It is an essential tool for creating huge changes in your life. It is a rare quality, often overlooked and missed out on by many people. Let me explain how. Take man A and man B. Both men are very unsatisfied with a particular part of their life, whether it be work, health, or skills, and so on. They both decide to do a little research and discover a course of action that will lead to the advancement they're seeking. It will be 3 years to obtain it. Man A decides to go for it. He says 3 years seems like a long time, but it will be worth it when I get there. Better late than never. Let's get started. Man B says 3 years feels like an eternity. There must be another way. I'll look at something else. It may not be exactly what I'm looking for, but at least I don't have to wait for so long. Fast forward 3 years down the line, man A has obtained the goal he desired. He has advanced substantially in his career, and as a result of this, several other areas of his life have improved too. He has more money as a result of his improved skill, and has much greater confidence, so he's doing even better in the relationship world. Man B has only progressed just slightly, but is still hugely unfulfilled in most areas of his life, and is now saying, I wish I would have just done that thing 3 years ago, and I'd have it today. Patience goes hand in hand with persistence, and I'm sure you don't need me to explain the benefits of persistence. What I'm saying is, when you're about to climb a mountain, don't spend too much time looking up at the peak. Just look at the path ahead and take the first few steps. You'll be there in no time. Thanks for watching, guys.
All right, on that note, I want to welcome you guys once again. And it's a privilege to be with you guys. And it's been a great session so far. So today we are going into another session. Well, the truth is that this is still a part of what we're going to do today is still a part of trigonometry. So it's just a continuation of trigonometry. And as I've said, as you guys are aware, it is bearing and distances. So let's get cracking. So if you have any question along the line, just put it in the chat box or you raise your hands, then I can take your question. All right. I say simply put, bearing can be defined as the clockwise angular movement between two distant places. So bearing is simply the movement between two places in angular form. Now, it is very important to note that when you are treating cases of bearing and distances, to take note of the angle, the angular movement. You can see I underline the word clockwise. That implies that you have to start from the north and you move towards the east, towards the south, and towards the west in that order. So if you are given any particular angle and any particular bearing and you want to locate the position, it is very important that you start from the North Pole, then you move in a clockwise direction. Then there are two main ways in which bearing can be represented. Bearing can be expressed in two main ways. The first one is called the three-figure bearing. That is when you have something like 060 degrees, 090 degrees, 130 degrees, 180 degrees, 300 degrees, and so on. So that kind of expression is referred to as the three-figure bearing. The other option is referred to as the compass bearing. The other option is referred to as the compass bearing. Now let me do a little illustration here. Let me put up the whiteboard. Pull up the whiteboard. Okay, so that I can illustrate the two. Now, you know, we said that for bearing, you start from the North Pole, you move clockwise. So the first thing is for you to draw your cardinal point. You draw your cardinal point, then you indicate your North Pole. Draw your cardinal point and indicate your North Pole. Now, if you move, this is north, this is east, this is south, and this is west. All right. So that's the 4 cardinal points. Now, what the definition is saying is that you move from the North Pole. If you are taking the bearing, you move from the North Pole in a clockwise direction like this. You move like that. You move in that direction. You don't move the other way. You don't move anti-clockwise. So your movement will always be clockwise. Please, if you have any question, you can type it in the chat box. So, for instance, if we have, let's assume we're supposed to have, they gave us a bearing of, let me draw this again. We have this our compass, and this is still our west. So we want to indicate the following bearing. For instance, they gave us 255 degrees. They gave us 060 degrees. They gave us 300 degrees. Now, if you are, as I've said earlier on, this style of notation of bearing is referred to as 3-figure bearing. 3-figure bearing. So, and you know, you should also put at the back of your mind that the movement from north to east, if you move from north to east, it is 90 degrees. You move from north here, from this place to this place is a 90 degrees. The same way, if you move from east towards the south, that's another 90 degrees. Then if you move from south towards your west, that's another 90 degrees. Then if you move from west towards your north, that's another 90 degrees. So the total movement, angular movement you can have at any spot, at any point in bearing is 360 degrees. So let's see how we want to represent this bearing. We want to represent this bearing on our compass. So I will, let me erase. Okay. So this is 255. So if we move from north to east, that is 90. Then from north to south, we have moved 90 in 2 places. That is 180. Then if we move from, let me name this as our west. So if we move from south to west, that's 180. That's from north to west. That would be 90, 90, 90, 90. So that's 270. So that implies that if we move from here up to this place, that would be 90 in 3 places, which is 270 degrees. But what we want to represent is 255. We want to locate where angle 255 will be. So what we do is, that implies that 255 is greater than, you know, this south is 180 degrees. and west is 270 degrees. 255 is greater than 180, but is less than 270. So our 255 will be in between south and west. So we can decide to move it this way and pause that like that, and we draw our location. So that then what you now do is you now indicate that this is 255 degrees. So this angle is 255 degrees. You know, because I can't put degree on this whiteboard. So that is 255 degrees. I hope that is making sense. So let's assume we want to do the second one. Let's draw the first thing as usual is to draw your cardinal points. Draw your cardinal points. Represent your north. The north is actually the starting point. You may not need to represent the east, west, and south, but the north is the most important because that's the starting point. So that's the north. So this time around, we want to move 60 degrees, 060. We know that if we start our movement from the north towards the east, once we get to the east, that is 90 degrees. So what we want is less than 90 degrees. So we can just say we move like this and draw our position. So that means this point is our 60 degrees. I hope that is making some sense to us. The same way, I want to believe that we can all do the third one. We can all do the third one so that because of time, let me move to the second method of representing bearing, which is referred to as the compass bearing. The compass bearing. Now, what the compass bearing does is the compass bearing takes into cognizance the 4 cardinal points. The compass bearing takes into cognizance the north, south, east, and west. So what we are saying is that so you have this to be our north, we have this to be our east, we have this to be our south, we have this to be our west. Now, what compass bearing does is your movement will always be from the north or the south. You know, for 3 degrees bearing, we said your movement will always start from the north, no exception. But for compass bearing, you move either from the north or from the south. Now, this is how the movement is. You either move from the north towards the east, or you move from the north towards the west. So for compass bearing, you either move this way or you move this way. Or you move south towards east or south towards west. That is why you can have something like, for instance, if you are given something like this, north 40 degrees east. I want to believe that we have all seen something like this before, or south 75 degrees west. Now, what this is telling us is that you will move from north, you will move 40 degrees towards the east. Then the second one is telling us you will move from south, you will move 75 degrees towards the west. So if we want to represent these 2 points on our bearing, what we would have is this. So we are moving not from north towards the east. So we are moving from north towards the east. We are moving 40 degrees. So this will be our position. So this will be our point. This will be 40 degrees. So the other one is saying we should move from south towards the west. So that means we'll move from south, we'll move 75 degrees. From south, we'll move 75 degrees towards the west, which we can assume that is it. Then we draw our location. So this, our angle, will be 75 degrees. I want to believe that that is all my illustration so far is making sense to us. So those are the two ways by which you can represent bearing. And those are the illustration of how you can locate the bearings of your points. All right, so let's go back to our presentation. So we have said this, bearings are usually expressed as either three-figure or compass bearing. Now, rules for solving bearing. These are not steps, but they are rules, what you must obey. I've explained some of them in the course of my trying to locate bearing. The first one is that you must take the reading starting from the North Pole in a clockwise direction and ends also at the North Pole. I've said that you start from the north and you move towards back to the north, depending on the degree you are given, how wide the angle is. Then I've also said this, I've also done this illustration that all the total bearing, the total angles formed while taking reading at every point in time in bearing is 90 degrees, 360 degrees. That is 90 degrees in 4 places. Then it is also worthy of note that all questions in bearing leads to the formation of a triangle. All questions in bearing leads to the formation of a triangle. All right. On this note, I would like to, so now this last statement will lead us into digressing a bit and looking at the tools. I call it the tools that we can use in solving questions pertaining to bearing. And this is referred to as, one of them is referred to as the sign rule. I know some of us would have heard about sign rule before. Sign rule is one of the methods of solving problems involving triangles. Please note that this is different from trigonometric ratio of sine. In this case, in the case of bearing, you may almost always be guaranteed that you will not have a right-angled triangle. And because you will not have a right-angled triangle, trigonometric ratios will not apply. Please, let's note that trigonometric ratios only apply to right-angled triangle. But sine rule applies to any form of triangle, irrespective of whether it is right angle, isosceles, scaling, or equilateral. So for any given triangle, the sine rule states that small letter a over sine capital A is equal to small letter b over sine capital B is equal to small letter c over sine capital C. Now, if you look at my triangle, you will see the notation. Small letter A is the side that is facing angle A. Small letter B is the side that is facing angle B. And small letter C is the side facing angle C. Whereas all the big letter alphabets, the big A, the big B, and the big C, are the values of the angles at, for instance, big A means the value of the angle at A. Big B, capital B, means the value of the angle at B. Capital C means the value of the angle at C. Now, it is not every triangle problems or every bearing problems that you will always use a sine rule for. There are some conditions that needs to be fulfilled. There are some conditions that need to be fulfilled for you before you can use sine rule. Now, the first one, there are two. The first one is if you have two angles and one side. If you have two angles and one side, you can use sine rule. Or if you have two sides and a non-included angle. Two sides and a non-included angle. Now, let me do a little illustration of what I mean by non-included angle. For instance, if we have, if I have this triangle, let's label this A, label this B, and label this C. Now, when they say non-included angle, for instance, if we know this side, this side will be small letter B, and this side will be small letter A. Now, if you are given small letter B and small letter A, what is referred to as included angle in this case is this angle. An included angle is the angle that is formed by two lines or two sides that you have been given. An included angle is the angle that is between two lines that you are given in any triangle, two lines that you know in any triangle. So if for instance we don't know B, we only know A, and we also know small letter C. So that means for this case, our included angle will be this angle, because it is that angle that is between A and C. I hope that makes some sense to us. So what we are saying in essence is that for you to effectively use sine rule, you must have two sides and a non-included angle. So that means if you are given side A and side B, you can only use sine rule if you know angle A or angle B. You can only use sine rule if you know angle A or angle B. I want to believe that that is making a whole lot of sense to us. So the other tool that we can also use is called the cosine rule. The other rule is called the cosine rule. Now, the cosine rule states that small letter A squared is equal to small letter B squared minus small letter C squared small letter A squared is equal to small letter B squared plus small letter C squared minus 2 multiplied by small letter b multiplied by small letter c cos angle A. The same way, you can use it to find your b. B squared is equal to a squared plus c squared minus 2ab cos b. The same way for c, c squared is equal to a squared plus b squared minus 2ab cos c. Then if it is angle that you want to find, this is how to use the cosine rule. All what they did was just to rearrange, was just a rearrangement of the subject of formula. And in the same way, I said A is the length facing side A, B, small letter b is the side facing side B, small letter c is the side facing side C. Then for you to use cosine rule, you must either know the 3 sides. You can see from this side of the formula, for you to find any angle and you want to use cosine rule, you must know the 3 sides. So that's one of the conditions under which you can use cosine rule. Then the other one is if you have 2 sides and the included angle. I hope you remember that when we were talking about sine formula, sine rule, we said you can have 2 sides and a non-included angle. But for cosine rule, that angle must be the included angle. So I hope that makes sense to us. So I want us to look at some illustrations. And all right, so let's look at some illustrations. And see how far we can go. Now, if we look at this, a bearing of 320 degrees expressed as compass bearing is what? So the question is asking us to convert this 3-figure bearing to a compass bearing. Convert this 3-figure bearing to a compass bearing. How do we go about that? Now let me share my whiteboard again. Now, so the question is 320 degrees. So we want to convert it to a compass bearing format. So the first thing you do, as usual, draw your cardinal point. And I've told us that we always start from the north. So this will be our north. Now, how do we move? This is 320 degrees. The first thing you do is, how many 90s? If you are taking it in 90s, where will this 320 degrees fall? If you are taking it in 90s, we are moving 90s, where will this 320 degrees fall? If we move from here to here, that is 90. Move from here to here, that's 180. So that means it won't fall there. Move from then, move to here, this is 270. Now, this is 270. This is This is 270. And this is, if we go back to this knot, that is 360. So that means our 320 will fall between 270 and 360 degrees. So what we do is we will subtract this 320 from, if we subtract it from 360 degrees, what do we have? Subtract 320 from 360, you will have 40 degrees. So that means the angular distance from the north angular distance from the north towards this will be our west. Angular distance from the north towards the west will be that 360 minus 20 degrees, minus 320 degrees. So that we will have 360 minus 320 degrees, which will give us 40 degrees. So that means we will now move 40 degrees from north towards the west. We move 40 degrees from north towards the west. So if we assume that we are moving this way, this is, let's assume our 40 degrees is there, then we'll draw our line. If we are asked to do the location, but we are not asked to do the location, but we are only asked to convert 320 degrees to compass bearing. So what this will now be in compass bearing is, because we move from the north, we will start with our north, so that we will have north. Then we move from north, we move 40 degrees towards the west. So 320 degrees as a 3-figure bearing is the same thing as north 40 degrees west. That's how you pronounce this, north 40 degrees west. So that means you move from north, you move 40 degrees from north towards the west. I hope that makes sense to everybody. So I want everybody to quickly do this. Our time is fast spent. So let's do 245. Let's do 245 degrees. Let's convert it to compass bearing. Once you finish converting it, you raise up your hands so that I can call you and get your answer. Thank you.